There's many different types of light waves. Light waves have an energy, and each energy has different properties. These energies have a wavelength and frequency, just like regular waves would have. But in general, the electromagnetic wave, the light, can be defined by its energy. And energy is what makes the difference between a light wave that we can see and all the light waves that we cannot see. If you'll notice, what we consider light to be, electromagnetic waves that we can see, is a very small portion. What we can see as a visible light is actually a very small portion. So this spectrum of electromagnetic waves is much greater than what we can actually see. And they've blown up the visible spectrum, the visible part of the electromagnetic spectrum, but you can see there's all sorts of other electromagnetic waves, light waves, that we can't see, and we're familiar with some of them. Radio waves are the same as what we consider to be light waves. They just have such a long wavelength and such a small frequency that we can't see them. They can pass through materials and travel over long distances, and that's why they're great for communication. Microwaves can interact with molecules and spin those molecules, and that's why we have microwave ovens, because there are frequencies in the microwave range that will spin water molecules, and those water molecules begin to heat up because we learned that temperature is just the motion of those molecules. So if you take electromagnetic waves in the microwave range that are the right frequency, that their wavelengths just fit the size of the water molecule, and start spinning them as fast as you can, they start to heat up because they bounce into other molecules and transfer their energy. So that's how the microwave oven works, using electromagnetic waves just like the light we see, except of a different energy range. Infrared is familiar to us for all of our remotes, our TV remotes that we use for the TV. They put out those pulses of infrared that interact with those sensors on the TV. Invisible light, which we're all very familiar with. We can see that every day in all of its different energies. And the colors that are in that visible spectrum of light are just different frequencies or different energies of light that we see. So the light that's different colors is different energies. Each color is a different frequency of light or an energy. And frequencies and energies can be going hand in hand because each frequency of light has its own unique energy as well. So you can either refer to it as a frequency or an energy of light. Both would be reasonable ways to refer to the light. And those colors are a spectrum of frequencies and energies. As we go past the visible light, we get the ultraviolet light, the bad stuff from the sun. This is the thing that can also catalyze reactions, all sorts of bad reactions in our skin. That's why it's dangerous to us. X-rays are the very short wavelength rays, high energy, that we use to look through soft material like our skin, but is still reflected off bone, the denser materials. And gamma rays are high energy radiation that we don't really even deal with here on Earth, that are really products of stars collapsing and black holes. So it's a long range of energies from our radio waves to a gamma ray. And we can see somewhere in the middle of a logarithmic scale, so it doesn't really mean the middle, but we can see a very small portion of the energy rays, electromagnetic rays that are out there.